Okay, today we're going to start on the sum and difference formulas for sine, cosine, and tangent here. And usually I prove these out, but I'm going to go ahead and save these proofs until later, simply because they're a bit laborious and tough to understand, and I don't want to scare anybody off here. So let's just kind of take my word for it at the moment here. And what the sum and difference trig formulas are is that for sine, cosine, and tangent here is that when you are adding to or subtracting the two angles right here, okay, that requires a different algorithm, okay? That means is that we're not able to go ahead and just distribute sine into each one of those. It plays out a little bit differently, as you can see on the right-hand side of the equal sign there. Something that we do want to mention before we move forward is that these symbols right here basically mean is that if this is a plus sign here, then it's going to be a plus sign here, and likewise if it's a negative sign here, it's going to be a negative sign here. However, so you notice that this is plus minus plus minus. However, if we go plus minus to a minus plus, that means whatever sign is here, say a plus sign, it's going to be a negative sign here, and likewise if it were a negative sign here, this is going to be a plus sign here. Okay, so that's how they correlate. So how are we going to do this out? So we got the cosine of 75 degrees here, and we don't really know what the cosine of 75 degrees is because we only know these guys right here, right? All these nice angles that we studied. And then as we run around the unit circle, we get more of those reference angles to the 30, 45, 60, and 90, etc., etc. So what we're going to do is that we're going to rewrite 75 as a sum of two known angles, okay? So what I'm going to do is that I'm going to start off by going the cosine of 75 is just going to be 45 degrees plus 30 degrees, okay? And now what we're going to do is that we're going to use the sum formula of cosine over here, and this basically says that if I have this alpha right here and this beta, then I'm going to, so this is the alpha right here and the beta right here, I'm going to have to put these into that formula, okay? So here we go. So I'm going to do it down below. It says the cosine of alpha, which is 45 degrees, times the cosine of beta, which is 30 degrees. Now this is a plus sign, and notice that this plus sign, that means is that we have an inverse or opposite relation here, and so it's going to go to a minus. So I got minus, and that is going to give me sine of alpha, which is 45 degrees, and sine of beta, which is 30 degrees. Okay, so now we're able to easily knock these things out using what we know about trigonometric ratios. So bringing this down, I got the cosine of 45 degrees is root 2 over 2. The cosine of 30 degrees is going to give me, and I'm just going to set these off with some parentheses there, root 3 over 2 minus cosine of 45 degrees, which is root 2 over 2, times the sine of 30 degrees, which is 1/2. Okay, and now we just need to clean this thing up a little bit. So square root of 2 times the square root of 3 is the square root of 6. And 2 times 2, that's just going to go ahead and give me 4, minus square root of 2, because that's a square root of 2 times 1, all over 4. And so at the end of the day, my final answer is going to be the square root of 6 minus the square root of 2 all over 4. And that gives me the exact value of this guy right here. Okay? So, and if you would check that in your calculator, you punch cosine of 75 degrees in, get an answer, plug that in as well, get an answer, you're going to see that they're going to be the exact same thing. Okay, so let's tackle this tangent of pi over 12 real quick. Okay, so the tangent of pi over 12. So pi over 12, we got to figure out how many radians this is. I'm sorry, how many degrees this is. And so, because this is, when you have something that is in radians, it's tough for students to set up a sum or difference that is going to really go ahead and make sense. Okay, so let's go ahead and let's find out how many degrees this is, and we're just going to do our simple formula over here, okay, that we did convert from radians to degrees, and I'm going to go ahead and plug in theta, which is going to be this guy. Okay, so and then knocking everything out, we know that this is, and I'm just trying to go through this real quick so we can get to where the rubber meets the road here. This is going to be what, 1/24th. Okay, and then we would have cross multiply, and we would get theta d is 15 degrees. Okay, so 15 degrees is a lot easier for us to manage, or probably visualize, than a radian of pi over 12. So what I'm going to do is that we're going to use the tangent formula here, and it doesn't matter which they're going to have the same values whether we pick these two or these two, because it's going to be the difference of 15. So let's just pick the smaller one, which is going to be the 45 and the 30, and see how that shakes out. Okay, so I'm going to rewrite this as the tangent of 45 degrees minus, okay, the tangent of 30 degrees. And so we're going to realize that this is the alpha and this is the beta, and we're going to be plugging it into this formula here, making sure that we keep our signs straight, because we got a direct relation, and then we got an opposite relation right here, so we got to watch those signs. Okay, so we have the tangent of 45 degrees. Okay, and since this is a minus sign, since that's a minus sign, it's going to be a minus right here. Tangent of 30 degrees. Okay, 1, and since that's a minus sign, this is going to be the opposite relation, so that's going to be a plus. So we got plus tangent of 45 degrees times the tangent of 30 degrees. Okay, oops, I'm just going to do it out like this, get it less confusing. Okay, so let's start cleaning this thing up. So we got the tangent of 45 degrees, which we know is 1, okay, minus the tangent of 30 degrees, which we know is going to be root 3 over 3, all over 1 plus the tangent of 45 degrees, which is going to be 1, times this guy again, root 3 over 3. Okay, so now we have this right here, and we got to clean it up a little bit. There's going to be some arithmetic that is going to go along with this. So stay tuned real quick as I write this out. Okay, so we can't have square roots on the bottom, so that means is that we're going to have to rationalize. So I'm going to make some room here. Okay, so we got a lot of arithmetic to do. And so putting this over here, what I'm going to do first is cut down these fractions, and I'm going to multiply the top and the bottom by a 3. Just to get rid of those fractions here. And that is going to, in turn, knock those things out. So that's going to give me a 3 minus the square root of 3 all over 3 plus the square root of 3. And now, the only way to go and get rid of the square root on the bottom is to multiply the top and the bottom by the conjugate. So let's do that. Okay, so written in black there is the conjugate, and so you notice that these are the same up top, so I'm just going to leave them be as 3 minus the square root of 3 squared. And now I have to go ahead and do some FOIL with these guys right here. So on the bottom, I'm going to get 3 times 3, which is 9, 3 times root 3, and minus 3, and then I have negative square root of 3 times the square root of 3, which is a minus 3. So what we're going to do is that we're going to cross these guys out, and on the bottom I have 9 minus 3, which is going to give me 6. So at the end of the day, after all of that arithmetic, we are going to get the exact solution of 3 minus the square root of 3 squared all over 6, and that is going to give me my exact value for that guy right there. And again, if you punch those both into a calculator, you see you're going to get the exact same thing. So that's how you do that, and we're going to be moving on to some other skills that have to do with the sum and difference formulas.